Greetings, fools. I'm Asit Sharma, Senior Analyst at The Motley Fool, and my guest today is Yoav Zeif, CEO of 3D printing pioneer Stratasys, symbol SSYS. Yoav has helmed Stratasys since 2020, and he brings years of prior product and C-level commercial experience to the role. He holds an executive MBA from the Kellogg School of Management at Northwestern University and a PhD in international economics from Bar-Ilan University. Yoav, welcome to The Motley Fool.
Thank you. Thank you for having me. I'm a long-term fan of The Motley Fool.
Great to hear. So let's start with Stratasys' story. At one time, about 10 or 12 years ago, this was a name that was familiar to most tech investors. It was the height of the interest in the 3D printing craze. I remember that time very vividly. Both the technology was extremely exciting and stocks associated with the technology were going up in rapid fashion. The market cap of Stratasys reached close to $7 billion, and today the company trades at roughly 1/10 of that value, although it's turning around. So I wondered if you could tell us about the last 10 to 12 years, the fortunes of Stratasys, and the additive manufacturing industry itself.
That's a great question. Thank you for raising it. So I joined Stratasys in 2020. I was a partner in the McKinsey New York office. And I had a long-term experience in chemistry. When I joined Stratasys, it was clear to me that I'm joining an industry which is not about if it will catch, but when. Because there are like essential values, 6 essential values that we can drive as an additive manufacturing industry that are must. And today already, additive manufacturing is not a nice to have, but a must have when you are shifting from rapid prototyping to manufacturing. But it took the industry 20 years to be there. So if I'll go back to those good times that you mentioned, it's a reflection of, I would say, hype versus value. So if you drive hype, it's very easy to become 7 million or 8 million, and there are many stories in our industry of those type of companies. But when you're driving real value, it's a completely different story. And as an economist, and I was teaching macroeconomics for a long time, overshooting is what we are experiencing now. There was an overshooting in 2013, 2014, when everybody was thinking that we will print everything with printers. And there is an overshooting now that, hey, what happened to the industry? In those years, and I would say last 20 years, between 2014 to 2025, I can take you through what happened to the industry practically. Before 2014, it was such a new, amazing technology, not in delivering the real parts and properties, but it ignited the imagination of everyone. And I call the 2012, 2014 hype, the hype of a printer in every house or in every home. Well, it's not practical. It will not happen. Maybe many houses will have printers, but it will not become a printer in every house. Okay? Because you need to be a hobbyist, you need to like it. It's not part of what people are doing. But that was a hype, and everybody reached those high valuations. And the two leaders that practically invented this industry, Stratasys, that invented 2 technologies, and we'll talk about it hopefully later, FDM and PolyJet, and 3D System that invented the stereolithography, were at the spearheads of this industry. Then there was kind of a realization in 2014, 2015, where people understood that a printer in every house will not happen. And suddenly there were also many newcomers to the industry because of the hype. And those newcomers, like Mark Ford and Desktop Metal and HP and Carbon and others, they practically took the growth of the industry between 2014 to 2020, to more or less the COVID time. And then there was the post-COVID area where there was another hype. I call it the hype of we will manufacturing everything with additive. This is also not realistic. We will manufacture a lot with additive, but not everything. And then there was another realization because of the macro situation of the inflation and the interest rate. We jumped from one regime of interest rates to another one, from 0 to 6, and suddenly there is another realization, and we see another overshooting downturn of the industry. But also it's very healthy because we see consolidation and shakeout of the industry. So this is what happened to the industry. One hype of a printer in every house, nice growth over time of the newcomers where 3D System and Stratasys are losing market share, and then the hype of the specs of we'll manufacture everything with additive, and now realization that it's a step-by-step, a must-have solution in some applications. And this is where we are now. But the nice thing that even if you take 2012 to 2025 and you look overall on the growth of the industry, hype or no hype, the industry is consistently growing. We are focusing on polymer. Lately, just 2 weeks ago, we added metal technology. Our overall market is growing, and Stratasys market share since 2020 improved dramatically. So this is the story. Now, what's the fortune of this industry? What's the outlook? How do I see the future of the industry? Overall, in additive manufacturing, there are 3 segments. Rapid prototyping is the first one. The second is manufacturing aids, or tooling, you can call it. And the third one is real end-use part, where we print the end-use part. We print a denture. We print a panel for an airplane. We build a part of a missile. The industry was born in rapid prototyping. It is now getting stronger in tooling or manufacturing aids and in end-use parts. Just to give you a ballpark, the rapid prototyping is a 16, maybe $17 billion industry. In this area, 3D printing is already a mainstream. You don't do today rapid prototyping without additive manufacturing, without 3D printing. It's around 50% of this value. So it says 16, let's say 8. The manufacturing aids, the tools, when you build a new car plant, 50 to 60% of the cost is tooling of this plant, because you need robots, you need the end arms of the robot. 60%. In this area, and by the way, this tooling, more or less the value of tooling annually, it's around $250 billion. Additive out of it is maybe 1 to 2%. It's nothing. And we have huge advantages there. Now we go to the third segment, which is real end-use parts. The value of the parts that the industry, all industries, are producing. We are talking about around $17 to $18 trillion value. The size or the share from this value that you can contribute to additive, do you want to guess?
In percentage terms?
Yes.
7 to 8%. I'm probably understating, but
Great.
go ahead.
Park it for a minute. Around 0.1%
Is
of
is
the
what you
value.
can contribute
We are really
eventually?
building end-use parts. Yes.
Oh, so today's value.
0.1% of today's value of
Right. I
end-use
think I
parts.
misunderstood your question.
It's nothing.
Go ahead. Yeah.
There is no reason. There is no reason in the world we will not be what you said. You have a great gut feeling. There is no reason in the world why we will not be 7 to 8%. You know what does it mean? It means that it's 70 to 80 times bigger industry than what we are now. So this is the story about the industry, and I can explain why we should be 7 to 8% and not 0.1%. I hope I gave
So
you kind of a high level of the industry.
wonderful introduction. And I want to have you answer this follow-up question before we move on to some other topics, which is from where you sit, which of these three phases of creating parts in 3D printing? So we have the prototyping stage, we have the tooling stage, and the end part stage. Where does it make most sense for you to focus your machines in your business, given that all three hold very large opportunity in the future? Or are you required to invest equally across all three phases?
So as the all industry, most of our install base and the industry install base is still in rapid prototyping. But what we are doing as Stratasys since I joined is said, hey, rapid prototyping will be commoditized over time. Our unique capabilities, and hopefully we'll have time to go over them, position us in the best place to capture the value from high-end, high quality, high performance parts that are suitable for tooling and for end-use parts. This is the future of Stratasys. This is the future of the industry. But Stratasys is leading the industry into those blue ocean, I would say. Why it's a blue ocean? Because the value is there. Rapid prototyping over time will be mainly served by desktop machines with good enough printing. And this is the right thing to do. But there is no value there. I'll give you an example. When you look at the material in 3D printing, which for me is material software is everything. This is the essence of the business model of us, because it delivers the properties and it delivers also the quality of the part and the value to the OEM. But when you look at the material today in rapid prototyping, in the low-end machines that are being used only for rapid prototyping, they account for 70% of the volume of material, kg or tons or whatever. But they account only for 20% of the value from materials. So this is not the future for Stratasys. The future of Stratasys is to lead the industry with a lot of conviction and with delivering real parts properties, accuracy, and cost per part into tooling and end-use parts, real manufacturing.
Yoav, let's go straight to those capabilities that you mentioned. And I hope we can work in a little bit of explanation of the technologies that additive manufacturing spans today. I remember from the old days, my son built a 3D printer. Today, that would be, I guess, your rapid prototyping example. Very basic polymers. Machine used to spit out layer over layer, and we would keep going by his room. Is that part done yet? It's pretty amazing how it printed in layers. But that's just really, again, the introduction to this industry. Today, how have your capabilities evolved? And you can include the different types of additive technologies. You can also discuss markets. That would be great.
One of the things that we as an industry are regretting, I would say, is the fact that there was a phenomena that we used to call push the box. Many companies became public, and you need to meet the quarterly goals. You are coming from this space
Absolutely.
or objectives. And then the best way to meet the goals is to ride the hype and to push as many box, in this case, hardware, to many customers. But hardware is only one small piece of the solution. In order to be successful with new technology, you need a whole set of tools that you are delivering to the customer so he can enjoy and create value. And this is the hardware, which has to be reliable, accurate. We'll talk about this as well. But you need also the right material, the right software, and you need enablement. So the application engineers and the people that will make him successful, because this is a new technology. Today, most of the engineers, hopefully in 10, 20 years, it will not be the case, because people that are coming now from the universities, like your son, are familiar with 3D printing. But today, most of the engineers don't know how to design for additive. So you need to enable their capabilities to design for additive manufacturing, and you need to service it. And all this is a full package that you need to deliver to the customer, so he will really capture the value and the unique value that additive can put in front of him and really transform his business. Because we can transform businesses, but we were pushing the boxes. And then when you push the boxes, and I love being in the field, and I met many of our customers, thousands of customers. In many of them, I saw some type of 3D printer that they acquired over the last 10, 15 years, sitting in the dark, either in the corner or in a unique room that they bought or built for those machines. And this disappointment is still hitting this industry very hard. So we have to go to break ourselves from this mentality. We'll push boxes, we'll have great revenues, we'll keep telling the story. No, we need to deliver the full package. And that's what we are doing as Stratasys. This is what's unique. We understand that we are moving to manufacturing. We are not there yet, to be honest. It's a long journey, but we are in the best position in the industry. We call it manufacturing readiness. And in manufacturing readiness, you need to deliver the full solution, the hardware, the material, the software, the service, and the enablement that will make the customer successful and will deliver the value that we are promising for so many years. And it's happening, and I have so many stories about it. And maybe I'll go one by one by the technologies, and then I can share some stories about it. So Stratasys, what is unique for Stratasys is this full integrated package. And this full integrated package is coming with first 5 different hardware technologies, with the largest material portfolio in the industry, with a software that on one hand deal with the CAD side of it and make sure that you can print. We call it GrabCAD Print. You can print in the best way. And another software, we call it GrabCAD Streamline, which allow you to manage your total workflow and operation and fleet of printers. Not to print specific print, but to manage the entire workflow. And we have a network of partners, more than 130, that can support it everywhere that you are in the world. So we have the coverage to support any customer anywhere in the world, and many, many application engineers that can take the hand of the customer and make sure that he's successful. Because it's a new technology, there will always be problems before you adopt it. But if there is the right person that can make you successful, you will be successful and Stratasys will be successful. So you take this package, and we start with the hardware. the hardware has to meet three major requirements. One is that you meet the part properties, the requirements of the customer. The brittleness, the strength, the temperature, the accuracy, you have to meet it. The second one is all about the part cost. We are promising a cost per part, and we need to deliver the cost per part. And the cost per part is the depreciation, it's the overhead, but mainly the material, the cost of the material. And then the third thing, it has to be reliable and repeatable, because it's not a one-off, it's manufacturing. When we thought about it, we came to the conclusion that we cannot deliver it only with two technologies. Why? Because every application requires different technology. I'll give you an example. In the car industry, I don't know which type of car you have, but let's assume you have, I don't know, an Audi or a GM or a Toyota.
Yeah, we drive
different
Toyotas,
features.
my family.
Great. We love Toyota. It's one of our biggest customers. They have all our 5 technologies. It's a great example. And they use it to reduce the time of developing a car and also for tooling. But let's take Toyota. It will take you from A to B. I have an Audi. It will take me from A to B. Our head in the US has a truck, a GM truck. It will take him from A to B. So it purpose-wise, you get the same results. A car, different feature, different luxury, different type, but takes you from A to B. In our industry, all the technologies are printing by layers. But if you want to print, let's say, this is a good example. This is a part of a Formula One machine, okay, of one of our customers. It's controlling the air that gets to the brakes. You need one type of technology. If you want to print a denture, you need a different type of technology. And if you want to print ends of arm of a robot, okay, that capture here let's capture something with vacuum, it's a different technology. So, but the same customers sometimes need different technologies. And if you come to him and say, okay, what is the problem? I have one technology and I would like to solve with this technology every problem that you have. You are not honest and you're not delivering the value. That's why we have 5 technologies. So take one by one. The FDM technologies and the PolyJet technologies are 2 technologies that Stratasys invented, because we are an outcome of a merger of Stratasys from Minnesota, the US company that invented FDM. Scott Crump invented FDM. FDM is for example, here I have a panel of a plane printed in FDM. This is very high temp, thermoplastic, strong parts, like the end of arm that I showed you of a robot is also from FDM. And it's mainly used in aerospace, in defense, and for tooling. This is the tooling technology. And we are the leader there. We have the highest and the strongest position and the highest market share. We are not focusing in the FDM that your son did in desktop. We don't care about this. This is prototyping, conceptual prototyping. We focus on the high-end application of FDM. FDM stands for Fused Deposition Modeling. Practically, it's a material extrusion. You have an extruder, and the extruder is running with a specific tool path, and layer by layer building those very complex parts. Stratasys invented it. The second technology that we have is PolyJet. PolyJet is material jetting. It's like your HP printer at home, if you have an HP or something like this, jetting. But we jet acrylic material, like some type of polymer. And we build very accurate, highly realistic parts. For example, it's very strong in dental and medical. very strong, and in high realistic prototyping. Give you an example. This is a partial denture that was printed. We didn't print the metal came, but we printed around it, inserted it into a unique proprietary technology that we have, where we can print in monoblock the teeth and the gingiva, because it's very accurate. Another example is anatomical models, where we need to, I had a part here somewhere here, where we need, for example, pre-surgery. The surgeon wants to get into the operations room, and he wants to try before. So when he's practically opening the body of the patient, he doesn't see it in the first time. Here you have an example of a model with a tumor. Okay, see the eyes and the tumor inside, and they are practically practicing. You can do it with PolyJet because PolyJet is multi-material and very accurate and multicolor and multi-material. FDM is not. Okay,
And Yoav,
it's not.
you all have a specialized or proprietary software that you developed for this anatomical modeling, correct?
Yes, thank you for asking. Yes, the nice thing of leading a 3D printing company is that I'm privileged, really grateful that I have the opportunity to touch the life of people. It's unbelievable. It's not every work that you do put you in such a position. I met, for example, a professor was in Mayo Clinic, who is, infant with heart problems, just, 1 day old, 2 days old, they have some problems, they need to run an open heart surgery for them. He said that our technology is the best technology they ever used, because he is practicing before the operations, and when we is opening those small chests of those infants, it's not the first time that he was there. It means that we are increasing dramatically the success of the operations, but also reducing dramatically the recovery time. But you need to practice on tissues, and we imitating the tissues of the body. To imitate the tissue of the body, we build software we call the printer DAP, Digital Anatomy Printer, and the software is Digital Anatomy Creator, DAC, DAC. And why you need it? Because let's assume that you are an orthopedic surgeon and you need to operate the same operations, but you need to operate an 80 years old lady and a 16 years old girl. Same operation, but the bones are completely different. So in order to imitate the conditions, we developed this software where the surgeon can, before printing, decide if this is a bone, a strong bone of a girl, or a soft bone of an old lady. So this is mind-boggling, but it is saving life, which is the most important thing. So this is the second technology, PolyJet. The third technology that we have, and now we are moving more to manufacturing, is P3 or DLP, direct light processing. And direct light processing is practically a projector that projects light on a layer in a vat, a layer of resin in a vat. It has catalyst inside, so it hardens this layer, and this is the way you build, layer by layer, you build parts. This is already a manufacturing machine, very accurate, very strong, and good examples are connectors, for example, because we get to 30 to 50 micron accuracy. which is very unique in a repeatable way, with very strong materials. And we can print flame retarded parts for airplanes, for fighters, and we are doing it. The fourth technology is SAF. SAF is practically what we call high-speed sintering. And it's the closest in terms of cost per part to injection molding. It's based on powder. You have a layer of powder, then you go over it quickly with some type of ink, with heads, print heads, and then where the powder was touched by the ink, it absorbs more heat. So we run over it with light, high temperature, create high temperature, and then it is melting the powder at this area, differentiating between a powder that doesn't have the agent to a powder that has the agent. This is the most affordable in terms of the cost per part, and it's highly used in everything that replaced injection molding, in industrial application, but also in drones. This is a good example. This is a drone that was printed with our SAF technology, as is, even without, there is no post-processing here. Why it's so nice? Because you get low cost for the part, but it's very light, because when you print layer by layer, you get significantly lighter parts, depends on how you design the part. So this is the SAF technology. And the fifth technology is stereolithography, and we are designing and producing it in the UK. And this is about large parts, very large parts, for prototyping, but also for tooling. And it's practically one of the first technologies was invented by the founder of 3D System. We are very strong there. And we are today 85%. This is highly used in Formula One. And Stratasys today is 85% of this market, the Formula One market. Why it's important to mention? Because Formula One is like no compromise allowed. Every bit of a second is crucial. And they selected Stratasys for their printers, and they use it. This is the part from Formula One that I showed you, with a unique material of Stratasys. It's called Perform. And it is being used for wind tunnels, because they need to make sure between races that the car is really as close as possible to the ground in every turn. And also they use it for molds, to put on it carbon fiber. So those are the 5 technologies. What is nice here, that when I come to a customer, let's say a defense company or a maritime company in Germany, that's a true story, and they ask them, okay, what are the problems? Where I can help you? Because I'm coming to solve a problem. I'm in the best position I can because I don't need to sell them what I have. I have all the 5 technologies in polymers. Now we have also metal, very innovative technology. But I can tell them, okay, for this application, if you need a wind tunnel, great, I have Perform. You want prototyping, accurate prototyping, I have PolyJet. You need conceptual prototyping, I also have PolyJet. You need drones to run 100,000 drones, I have SAF for you. It puts Stratasys in the best position going forward to address real manufacturing needs.
Yoav, I appreciate you giving us such a great explanation on where the company is today and its capabilities. So, putting this all together, again, you're an economist, and you mentioned some of this. You have this whole sort of stream of value to the customer from the printer to the software to the services, but almost most importantly to the materials. And it's become apparent to me studying the company and listening to you today that the material side of it, as you mentioned, is much more important to the business model than maybe we understood several years ago about Stratasys. It's become more important, and you all have actually made an acquisition or two on this front. So I was wondering if you could explain a little bit why materials are so important, how you see that evolving over the next few years as you scale out the business and try to reach more, I would say, mass manufacturers, capture some of that very big market in turn.
No, that's a great question. Material is everything in our industry. And after it, it's software. Because the hardware is kind of the base, but on the base, what makes the difference is material and software and service. And by the way, I'm here. I was selected to be the CEO of Stratasys because I was running for 6 years R&D chemistry in a large chemical company. Don't ask me how I got there. It's a different story, but I'm attached to chemistry and to materials because the innovation there is endless, and it can make the difference between delivering the promise to customer or not delivering the promise to customer. And for me, it's everything. So let's talk about material for a minute. We have a customer advisory board, industrial customer advisory board. We meet every year in the US. 14 heads of additive manufacturing in the largest corporate in the world. Boeing and Airbus and Lockheed Martin and Ford and GM and Toyota, and sorry if I miss someone, but 14 of those. And we are sitting there with them for 2 days and asking them what Stratasys can do for you on AI, on material, on design, on software, and sustainability, by the way. And then every year we select like 3 work streams and we run it for the entire year and make sure that there is progress. And they are coming again and again because they see the progress. They also want to be successful. We want to take the industry into manufacturing. And they told me more than once that overall there are only 4 things that they care about. Only 4 things. The part properties, I already mentioned it. The cost per part, the reliability and repeatability, they call it efficiency. They measure it with OE, overall equipment efficiency. So the uptime of the machines, because it's manufacturing, and enablement. And to meet those requirements, you have to have material and software. It's impossible to meet it only with hardware. It's impossible.
The hardware
So
becomes
if we
almost
really
table
listen to
stakes.
our customers,
I mean, the hardware almost is a given in this case.
exactly, hardware is the table stake. And to meet their requirement, you need the material and the software. But let's start with the material. Because material and software improve the adoption. If I have material that meet your requirements, high temperature, no brittleness, elongation at break, I meet the requirements, he will buy the machine. He will buy the solution. They will buy the solution. Material is critical and also software for profitability. Hardware at the end has to be commoditized. You know, I'm an economist. I believe in it. You have innovation. At the end, everybody can put an extruder on a gantry. Everybody can buy a projector and put a VAT on it. Better, but very hard to put it together and make it a whole workflow. And after I sold the machine, the only thing that can support profitable business model that will allow us to reinvest in R&D is material and software. We need recurring revenue. And this is what's unique in Stratasys. We are the only profitable public company in additive manufacturing. Not profitable as we want to, because so many pressures and the change that we are experiencing and the move from rapid prototyping to manufacturing and the entrance of new Chinese players. But bottom line, if you have a direct strategy that is based on recurring revenues, and you know that we will be in manufacturing, like I described at the beginning, it is a sustainable business model with double-digit EBITDA and double-digit growth. And this is the target. Will not happen without material. So what we have done in order to be there, the number one thing that we have done is that we are allocating a lot of resources to material. Significant amount of resources. In every technology, we have material that we are building. And we acquired material companies. We acquired the Covestro additive manufacturing unit with plenty of materials, with a lot of patents that will serve us for many years. Because once you have a patent in a certain family of patents in certain chemistry, you can run it for a long time because you're kind of creating the barriers around it. And then there is the motivation to invest more in research around this family. So Covestro. We also acquired the additive manufacturing unit of BASF. It was called Forward AM. Again, many patents family with a lot of unique materials. We also acquired a small company, Nexa, with some materials. And we put all of them together into what we call IM Marketplace. And we launched it 2 weeks ago in Formnext, in the largest trade show in Frankfurt, largest global trade show of additive in Frankfurt. Why we have done it? Because we understand that for adoption, again, just listening to our customers, for adoption, we need to lower the cost of the material and to improve the properties of the material. It cannot happen without scale. Now, we are a small industry. How you create the scale? You need to put together many demands from different companies and to collaborate. I'm coming from the chemical industry, as I mentioned. In the chemical industry, the trick or the recipe for success is that my input is your waste and vice versa. And you make a lot of money on it. 80, 90, 70% gross margin. Because it's all about making sure that there is no waste. We, in the additive manufacturing, we are very, I wouldn't use bad words, but we have a lot to improve on collaboration. So we put together all those companies and we say, guys, we are willing to produce and sell material to everyone, to all other companies. And we got really good traction. So in this launch in Formnext, there were 12 other companies that took part of this launch because we are producing materials to them. Because the moment we will have scale as an industry and we will collaborate, we'll be able to reduce the prices of material, and then adoption will grow significantly.
Almost reminds me of
material, bottom line.
Open source type strategy.
Exactly. This is exactly the case. Asit, you're right. This is exactly the case. And what do we do here? Bottom line, more material that meets the part properties, the requirement, with lower cost, mean more adoption and more additive in tooling and in end-use parts.
Yoav Zeif, I really appreciate your time today. I feel like we just scratched the surface, but you've described the company as it stands today and really provided a lot of insight onto what is going to drive revenues and margins for Stratasys going forward. It's still such a fascinating company, and I hope that we can have another conversation in 2026 to follow up.
I would love it. And thank you for the opportunity. It was a pleasure. We really only scratched the surface. I hope you see that we are in Stratasys as a culture. We are highly passionate. It's not only me. And I want to say big thank you to all my employees. We're almost 2,000 employees and my team. The spark in their eyes is even brighter than in my eyes.
Well,
So
if they're anything like you,
I'm
I can see that's a lot
Thank
of
you very
spark.
much. And I hope to see you in 20,
Thank you as well.
and I hope to see you in 2026. Thank you, Asit.
We'll do it. We'll do it.